Right, so we've got a bunch of bedding data. Okay, so you can see if I look at this map that we have beds that are dipping to the east and then they change to dipping to the west. So it's worthwhile just marking on the form of the fold. Okay, so I can put a form line there that just shows the form of the fold. You can see as you come across here that there is a one bedding measurement that's in the hinge of the fold, and then the bedding reverses again. Okay, so it's steep on this side. Alright, so I can mark in the form of the fold like this. And by doing that, I actually make my cross-section drawing a lot easier, because I can look down the plunge of the fold and I can see what my cross-section is going to look like. Okay, so as I look down the plunge there, I can see the cross-section. Alright, because a map view is just a horizontal cross-section through a dipping feature, whereas a typical vertical cross-section is also just a vertical cross-section through the same feature. Okay, so they're going to be quite similar. So we've got strikes and dips of bedding, and what I'm going to do is I'm just going to plot all of the east dipping bedding. Okay, I'm going to circle east dipping bedding, and then I'm going to plot west dipping beds, which I'm circling in blue, and then after that I'm going to plot cleavages that I'm circling in red. Okay, cleavages are planar features, so they plot as planes on the stereo. And when I've finished that, then I'm going to plot the intersection lineations, which are linear features, so they plot as points on a stereo. Okay, so there's one there and one there. Right, so let's start off with the east dipping planes. The first one has a strike of 14 and a dip of 83 to the east. Okay, so a strike of 14 there and a dip of 83 to the east. So I'll count in 83 degrees and put that plane in. And I'll put the pole to that plane. So that basically I count 90 degrees from there across, put the pole to that plane. Then I look here and I've got another one that strikes 18 and dips 85 to the east. Okay, so what I'm actually going to do is I'm just going to plot the strikes of all of the east dipping planes and write their dips next to them. Okay, so I've got 18 dipping 85, so that is 18, and that dips 85. I have one that is 19 dipping 88. And I have one that is 10 and dipping 76. Okay, so now I can just rotate that round, and I know that it's dipping 76, count in 76, 70, 76. rotate it further around. I know that that one there is labelled 85, so that's obviously dipping 85. Count in, let me just go back and put the pole in for this plane. 76. And 85. So 80, 85. The pole to that is going to be over there. Put the plane in. And that last one is dipping 88. Put the pole in. It's 88. Put the plane in. Near 90 degrees. Okay, so you can see in general I've got kind of a smeared out intersection up there. So now I'm going to plot all of the west dipping limbs, which I've circled in blue. So we've got 222. Let's just mark all the strikes on. Okay, we've got one that is 222 and dipping 45. I'm just going to label that 45. And I've got 217 dipping 51. Label that 51. I've got 229 dipping 40. Label that 40. And 218 dipping 48. 218 dipping 48. Okay, so I can move those out of the way. Put that one. These are all dipping to the west. Okay, so I'll put this on the south point. That one is a plane that dips 51. Count in 10, 20, 30, 40, 50, 51. And then 10, 20, 30, 40, 50, 51. There's the pole to that plane. And the next one is dipping 48, striking there and dipping 48. So 10, 20, 30, 40, 48. And count out 10, 20, 30, 40, 48. And then I've got one that dips, strikes about there and dips 45. 10, 20, 30, 40, 45. And a final one that strikes there and dips 40. Okay, 10, 20, 30, 40. Let's look at the one in the hinge. This one here strikes 293 and dips 27 degrees. Okay, so let's just put that in, and I'm just going to dot it in. 293 is there, and it dips 27 degrees to the north. Okay, so there's 293. North is over this direction, so I'll count in from this side. 10, 20, 27, and I'm just going to kind of put it in dotted in this colour because I haven't put another colour aside for it. And then 10, 20, 27, and that's the pole. Okay, so I've missed out putting in, so I've put the pole for the 51 and that one, didn't put the pole for that one, that was 45, 10, 20, 30, 40, 45, and I didn't put the pole for that 40, so let's put that in, 10, 20, 30, 40. You can see why labelling them with their dip lets you put the poles in afterwards if you realise you've missed a few out. Okay, so now I'm going to now I can show already two important features. I can show the beta axis, which is here, and I can show the pi axis because I can lay these on a common great circle that is probably going to lie somewhere there. Okay, you can see it's not a perfect fit, but it's going to be somewhere there. Let's hope this yellow shows up on the video. And the pole to that, okay, you can see the plane is dipping 10, 20, 30, 40, 50, 60, about 65 or thereabouts. So I count out from here, 10, 20, 30, 40, 50, 60, 65, and that there is my pi axis. Okay, so I'm going to label that pi axis, and this here is the beta axis. Okay, so those two things are now labelled on there. So now if I put the cleavage poles on, okay, I've shown the cleavages in red on there, I've circled them in red. So we have 3 cleavage measurements, and I'm going to put each of them on. So we have one with a strike of 208 degrees and a dip of 63 to the west. So 208 and a dip of 63. And we have one with 210 and a dip of 70, and one with 216 and a dip of 72. 216 and a dip of 72. Okay, so if I take those, put them, that one there, it's got a dip of 63 to the west. Okay, well there's west over there. So come in 10, 20, 30, 40, 50, 60, about 63. And I've got an axial planar cleavage that goes through there. Alright, the pole to that axial planar cleavage is 10, 20, 30, 40, 50, 60, 63. It's over there. It lies very close to the pi circle, okay, which is what it should do. Okay, so now we've got another one over here, 70. I'm only going to show the pole for it. Count out 10, 20, 30, 40, 50, 60, 70. Lies just the other side of the pi circle. And one over here with a dip of 74. 10, 20, 30, 40, 50, 60, 70, 74. That one is a little bit wild out the side. Okay, but what those things tell me is that I've got the poles to my cleavage planes, which are axial planar cleavage. They're subparallel to the axial plane, are in this area here. So I pick out my two limbs, and I've got a limb there, and I've got a limb here. Circle those limbs, and now I'm going to bisect that angle to get the interlimb angle. So I'm going to count from there, okay, approximately there. That's and I'm going to count 2, 12, 22, 32, 42, come back in another 2, total of 44 degrees. So my interlimb angle is about 44 degrees. I take half of the interlimb angle, okay, which is about 22 degrees, and I count 2, 12, 22. That there is the pole to my axial plane. Okay, so I'm going to circle it in green and write PAP, the pole to the axial plane, and I can now draw the axial plane. Okay, I use that pole to the axial plane. You can see that it has a plunge of 10, 20, 30, 40, 50, 60, 72. Okay, so the axial plane is going to have a dip of 72. 10, 20, 30, 40, 50, 60, 70, 72. So I can draw in my axial plane, which, as you'll see, is quite close in its orientation to the axial planar cleavage, as it should be. Okay, so there's the axial plane, and I'm going to label that axial plane. Alright, so the what is the orientation of the axial plane? Well, if I put that back north-south, I can see that it has a strike of 20, 22, 24, 26 degrees and a dip of 72 degrees. So the orientation of the axial plane equals 0 to 6, 72. Okay, and it's dipping to the west. Okay, so that's that question out of the way. 0 to 6, dipping 72 to the west. So draw an unexaggerated cross section. Okay, I'm not going to do that for you, because you can draw your own cross section, but you can see that I already now know what the orientation of the trend and plunge of the fold hinge is. Okay, I can measure the trend and plunge of the fold hinge on here. Okay, so I'm going to use the pi axis as the best estimate for the trend and plunge of the fold hinge, and I'm just going to draw it in there. Alright, and it has a plunge of 10, 20, about 25 degrees. Okay, and a strike of about 19. Okay, so the fold hinge plunges about 25 degrees towards 019 degrees. Okay, so there's the azimuth, that's the plunge. Alright, so what if I've got a fold hinge that plunges towards 19 degrees, okay, I will put in my 19 degrees approximately on here, and I will draw my cross section perpendicular to 19 degrees. Okay, so my cross section line will come through there. Alright, starting from the starting point that I've given you. Now we've got a paleocurrent rotation problem. Okay, so we've got a paleocurrent indicator at A, okay, which is on the 01885 east dipping bed. Okay, so there's that's that bed there. Okay, you see that I've labelled it. The paleocurrent indicator is on that, and it plunges 42 degrees towards 188. Okay, so I go around to 180. Right, come around here to 188 degrees. There's 188 degrees, and I come in, plot the paleocurrent direction as a line. Okay, the paleocurrent direction as a line, and so I've come in 42 degrees. 10, 20, 30, 40, 42 degrees. Okay, so there is my paleocurrent. Now that bed is on. Well, the other thing I'm going to do is I'm going to circle the pole to that bed, which is that pole there. Okay, so that bed, I need to rotate that bed flat to find out what the paleocurrent orientation at the time of deposition was. But first I need to remove the trend and plunge of the fold hinge. I need to take the fold hinge, bring it back horizontal, and then rotate the bed flat. Okay, so the first thing I'm going to do is take the trend and plunge of the fold hinge and make that horizontal and rotate the paleocurrent at the same time, and the bedding plane, the pole to the bedding plane as well. Okay, so to get the fold hinge horizontal, okay, we've already said that the fold hinge plunges 25 degrees, so I'm going to have to move 25 degrees along this line to get the fold hinge horizontal. Okay, as I move 25 degrees, this paleocurrent indicator here also needs to move 25 degrees. So it's going to move 8 degrees, 18 degrees, and then another 7 degrees. So it's going to move to there. Okay, and at the same time, this bed here, this pole, needs to move 25 degrees in the same direction. That's a little bit less easy to do on this, but it basically just moves to there. Okay, so I've just counted around 25 degrees, and I promise you I won't give you one where you have to try and do rotations in the edge of the stereo net, because it's too difficult. Okay, so that there is now the pole to the bedding after you've rotated the fold hinge to horizontal. So we're going to call this pole to bedding prime. Alright, and this one here is pole to the paleocurrent prime. Alright, so now I need to take that bedding and I need to rotate the bedding to horizontal. But as you can see, it's at the moment it's dipping very steeply. Okay, as I rotate it to horizontal, you can see I'm going to move this pole to bedding by, if the bed is to be horizontal, the bed's going to be horizontal, the pole has to be vertical. Okay, so I'll move the pole into the middle. Okay, so I'm going to move it 5, 15, 25, 35, 45, 55, 65, 75, 85 degrees. Okay, and at the same time I'm going to move this paleocurrent 85 degrees. Alright, which is 5, 15, 25, 35, 45, 55. Hang on a second, where's that? Sorry. Oh, there it is. I was removing the wrong one. There's paleocurrent prime. Okay, 5, 15, 25, 35, 45, 55, 65, 75, 85. Can you see that once I rotate that paleocurrent completely, it ends up on the primitive circle? Okay, and that's because that paleocurrent is a line on a bed that is now being rotated to horizontal. Okay, so this is the original orientation of that paleocurrent. Okay, and we can now simply measure the strike starting from here. So we just look at the numbers here. We've got a the paleocurrent direction is towards 135 degrees. 135 degrees was the original paleocurrent direction. Okay, so I'm going to stop the video there and I'll stick that online so that you can go back through it again. Alright?